Hi, this is Stephen Brower from Mountain Valley Community College. This is for CSIT 256 Computer Architecture and Assembly. And this is meant to expand on two topics, one on the idea of multiple cores and the other on the idea of benchmarks. First, what this is supposed to show here is sort of like an old-fashioned computer, and we'll step into a more advanced one a little bit, but the control unit, the arithmetic logic unit, the floating point unit, and then a single instruction register. And so when the instruction, or when an instruction, this instruction 1 is fetched, it's brought into the instruction register. So at time 0, this is showing the fetch of instruction 1. Then at time 1, instruction 1 is going to be decoded, and part of the decoding is figuring out who's going to carry out the work. At time 2, instruction 1 is going to be executed. So either the arithmetic logic unit or the floating point unit or the control unit will carry out that instruction 1. And then time 3, if instruction 1 was sending something back to memory, then the control unit will handle getting that data back to memory. And then at the next point, the next instruction is fetched, instruction 2. So at the next point, instruction 2 is fetched. At the next unit of time, instruction 2 is decoded. At the next unit of time, instruction 2 is executed. Hopefully maybe this shows here that only 1/4 of the time is an execution taking place. Which would mean that potentially only 1/4 of the time, the arithmetic logic unit or the floating point unit would be carrying out work. So the idea with pipelining is to create additional units in the CPU so that fetching and decoding and storing can occur at the same time as the executing, just on different instructions. So by adding to the CPU a prefetch unit, a decode unit, a bus interface unit, then when a fetch takes place, it's a whole bunch of instructions, a block of instructions. And later when we get to chapter 4 in cache, we'll see how blocks of data brought in from memory into the cache. But on the fetch, so the prefetch unit would fetch the entire instruction set. So now, this entire block of instructions. And so with that instruction 1 being fetched, which actually fetched all the others, at the next unit of time, well, the decode unit can be decoding the instruction 1, and then the instruction 2 here is already fetched. At the next unit of time, that instruction 1 can be executed by the arithmetic logic unit, floating point unit, or control unit. And at the next unit of time, then that instruction 1, if there is any results going back to memory, is the bus interface unit that can bring that data back to memory. But what would show at this unit in time is that instruction 1 is being stored, instruction 2 is being executed, instruction 3 is being decoded, and instruction 4, well, either already has been fetched or is being fetched. And so at the next unit of time, instruction 2 is being stored, instruction 3 is being executed, instruction 4 is being decoded, instruction 5 is being fetched. So now at any one point in time, there potentially could be 4 different instructions that are in different parts of the machine cycle. The instructions are being executed in order, meaning 1, 2, 3, 4, they're being executed in order, but there's just multiple things that are going on at the same time. This is called pipelining. And so pipelining allows multiple instructions to be in the pipeline at various points in time. Where are we talking about this? Core. So a core on the CPU would be all the things that would be needed to do an instruction stream. Another core would do its own instruction stream. Each core would have its own instruction cache, and it would be doing the fetch, decode, execute, store for those set instructions that it has. So a CPU with 2 cores, one core can be working on one set of instructions, another core can be working on another set of instructions, aka another process. So 2 different processes can be going through these 2 different instruction streams, and that means that at any one point in time, now 8 instructions are being handled. 2 executing, 2 are being stored, 2 are being executed, 2 are being decoded, 2 are being fetched. So then with more cores, so if you have 7 cores, then there's 7 instruction streams that can be going through simultaneously. So this, when we talked about the multiple cores, now there is a different diagram in the book than the one that I did. I stepped through it a little bit differently, but hopefully conceptually, I was trying to get across the idea of what the cores are. So the core are the components of the CPU that will handle a sequence of instructions being executed, and we can have multiple cores on a CPU, each core handling its own sequence of instructions that are being executed. The other thing I want to sort of make a comment about then is benchmark. Now our book is showing the, well, let me jump over here to the SPEC 2006, I think is the one that our book is referencing. 2017 would be the later version of the SPEC that's out there. So I'm at spec.org, CPU 2017, and if I scroll down and take a look here and look at the benchmarks, then these are the benchmarks. So there's these sets of programs are being used. So it's 4 suites of programs. So these set here are for integers. These set here are for floating points. And sort of this batch is dealing with rate. This batch is dealing with speed. And as you can see, they're done in different languages. So over here we have C, C++, Fortran. Here we have Fortran, C++, C. Well, they're doing different things. So with the benchmark, it's a series of programs are run. The geometric mean is calculated for each one of them to then come up with a number. And so by having the same suite of programs run on a processor, then it's a way for seeing how that processor handles with this sort of suite of benchmarks. So I just wanted to, sort of as a deviation from what the book has, show that the spec.org website does show the a little more information about what is currently being used there. I think that's enough for now, isn't it? I think.